Hello friends, welcome to my channel. In this video we will discuss SSC JE 2020 solution. Question number 178 onwards we will solve. Only technical part we will solve. This is part 7 of this video series. Already discussed up to question number 177 in my previous videos. So question number 178, if fluid properties in a flow are constant with space at any instant of time, the flow is termed as dash. So with respect to space, already discussed, any property with respect to time not changing, this is steady flow. With respect to space, your uniform flow. So with respect to space, answer is uniform flow. If they will ask with respect to time, fluid properties in a flow are constant with respect to time, then it will become steady flow. Which of the following process is not comprised by diesel cycle? So diesel cycle we will discuss. PV diagram. One to two compression, then heat addition, 2 to 3 constant pressure heat addition, 3 to 4 expansion, 4 to 1 your exhaust. Heat addition or Q supplied, Q rejected. In diesel cycle, heat addition is your constant pressure heat addition, 2 to 3 is your constant pressure process. This one your isentropic process, PV to the power gamma equal to constant, PV to the power gamma equal to constant. Compression and expansion both are isentropic process. And your exhaust process is constant volume process in case of diesel cycle. And in case of Otto cycle you will get PV diagram like this. One to two isentropic compression, 2 to 3 constant volume heat addition, Q supplied constant volume process, 2 to 3, then 3 to 4 expansion, PV to the power gamma equal to constant or isentropic process, then 4 to 1 Q rejected or exhaust process. Which of the following process is not comprised by diesel cycle? Addition of heat at constant volume. Yes. Addition of heat in diesel cycle, it's constant pressure process. But in case of Otto cycle, it's constant volume process. 2 to 3 is your addition of heat. So, A is your correct answer. This is for Otto cycle. It's not for diesel cycle. Then B, adiabatic expansion and compression. Adiabatic expansion and compression, both this one, 1 to 2 expansion, sorry, this one compression, this one expansion, 3 to 4 expansion and 1 to 2 compression, both in Otto cycle and diesel cycle. Expansion and compression both are adiabatic or isentropic, reversible adiabatic or isentropic. Then rejection of heat at constant volume process. Diesel cycle, this one, 4 to 1 is your rejection of heat at constant volume. In Otto cycle also it's constant volume process. Addition of heat at constant pressure. This one, addition of heat at constant pressure, diesel cycle. So B, C, D all are correct options. Means the following processes are comprised by diesel cycle but not comprised by diesel cycle. Addition of heat at constant volume. It's in Otto cycle. So A is your correct answer. The next question. In an isentropic process, the pressure P of a gas varies with temperature T as P equal to K to the power 5 by 2, where K is constant. The ratio of gamma Cp by Cv value we have to calculate. So it's a isentropic process. Isentropic process or your reversible adiabatic process. P equal to K T to the power 5 by 2 given. Gamma value you have to calculate. Cp by Cv value you have to calculate. Then P2 by P1 how much you will get? K is your constant. So K T1 this is T2 to the power 5 by 2 by K T1 to the power 5 by 2. K is your constant. K cancel. Then how much you will get? T2 by T1 to the power 5 by 2. And we know one pressure temperature relation for your polytropic process and here for isentropic process it's available. This one you have to remember. P2 by P1 equal to T2 by T1 whole to the power gamma by gamma minus 1. So here also you are getting, so gamma by gamma minus 1 it's equal to 5 by 2. Then you just have to solve this one, you will get your answer. 2 gamma equal to 5 gamma minus 5, then 3 gamma equal to 5 gamma equal to 5 by 3. Options we will check. 5 by 3. C is your correct answer. Only thing you have to remember this one. Pressure and temperature relation for adiabatic process. Question number 181. The reaction and bending moments at point A of the cantilever beam are. This is a fixed support cantilever beam. We have to calculate at A point reaction and bending moment. There is no horizontal load, so you will not get any horizontal reaction. RA equal to 0. What vertical reaction you will get? RA vertical it's not equal to 0. And movement also MA it's not equal to 0. Both value we have to calculate, MA and RA vertical load. So clockwise we will take bending moment, clockwise we will take positive, anti-clockwise we will take negative. And vertical load you will take positive, downward we will take positive, upward we will take negative. Three loads are there. 15 kilonewton, then your 5 kilonewton, then 10 kilonewton. Distance how much? 3 meter, 2 meter, 1 meter. We have to calculate. RA and moment at A point. We know for equilibrium, all summation of all vertical loads, it should be 0. Summation of all vertical loads, it should be 0. So downward we will take positive 15 plus 5 plus 10 minus RA, it's equal to 0. From here RA value how much we will get? 30 kilonewton. So we can omit option A. Then summation of all moments, it should be 0. For equilibrium, so 15 into 6 plus 5 into 3, 10 into 1 minus MA, because MA is anticlockwise, equal to 0. From here MA we will get minus 115 kilonewton meter, or we can write 1 meter anticlockwise. So from option we will check 125, this one MA equal to 0, so CD not possible, B is your correct answer. RA equal to 30 kilonewton, MA equal to minus 115 kilonewton meter. In a bucket of water, piezometric head depends on it depends on your vertically how much it is dipped. So it depends on the height. Options are increases linearly in vertical direction, remain constant. No, it's not remain constant. If you increase your depth, then your piezometric head it will increase. So remain constant not possible. Increases in horizontal direction, no. In horizontal direction it's constant. Decreases in horizontal direction, this one also not possible. Increases linearly in vertical direction. It depends on your depth. If regeneration is used in Rankine cycle system under ideal condition, efficiency dash equal to, I think some printing mistake is there. No. Dash Carnot cycle. It will Rankine cycle and your Carnot cycle comparison in regeneration ideal conditions, under ideal condition. So it will be same as Carnot cycle. Rankine cycle efficiency, it should be same as Carnot cycle. Will be more, will be equal, will be less than, maybe more than. So B is your correct answer. In ideal condition, with regeneration, Rankine cycle efficiency, it's equal to Carnot cycle efficiency. Then next question. Air is compressed isentropically in a single stage, single acting compressor from an initial condition of 1 bar. So P1 equal to 1 bar and T1 equal to 30 degree centigrade to 5 bar. P2 equal to 5 bar. Gamma value given 1.4, R value also given 287 joule per kg Kelvin. Sometimes they are asking this unit also. So this unit you have to remember. Work of compression for unit mass flow rate. So m dot equal to 1 kg per second, or m equal to 1 kg. Flow rate of air is 5 to the power 0.286, equal to 1.584. You have to calculate work done value. You have to calculate work done in compression of unit mass. So data you will write P1 equal to 1 bar, T1 equal to 30 degree Celsius, then P2 equal to how much P2? 5 bar, gamma 1.4, R value given 287 joule per kg Kelvin, m dot value given 1 kg per second, work of compression you have to calculate. 5 to the power 0.286, it's equal to 1.584. Work of compression WC n by n minus 1 MRT P2 by P1 whole to the power n minus 1 by n minus 1. This is your formula. So again we will use our formula T2 by T1 for polytropic process, P2 by P1 whole to the power n minus 1 by n. From here T2 value you can calculate. T2 equal to T1 is how much? 30 degrees Celsius plus 273, 303. 303 into 5 to the power 0.28. 5 to the power 0.28, it's 1.58. So 303 into 1.584. Then n by n minus 1 AMRT, instead of P2 by P1 we will write T2 by T1 minus 1. N value 1.4 by 1.4 minus 1, it's 0.4 into 1, m value given m dot, then 287 into T value, T1 value 303 into T2 is how much? 303 into 1.584 divided by 303 minus 1. So how much you will get? 14 by 4 or 2 by 7. So 3.5 you will get. 3.5 into 287 into 303, 1.584 minus 1, you will get 0.584. Again approximation you have to do. 287 you take 290, then this one you make 300. How much you will get? 290 into 300 you will get 87. 87 into 3.5 into 0.5 you will get 1.7. If you multiply, here how many zeros? 3 zeros. If you multiply, finally you will get 147, approximately 150 you will get. So this original value, it should be greater than 150. From option we will check greater than 150. C is your correct answer. It's a time taking question. You have to remember this formula, then this relation, then approximation value you have to put. Then only you can solve this type of questions. It will take around 1 minute it will take. If you are good in approximation method, then within 1 minute you can solve this type of question. But you have to remember this formula. This one and this one. These two formulas you have to remember. Then next question. Operating pressure for once through boiler. Once through boiler means supercritical boiler. Operating pressure is 221 point something, 221.2 bar. This is your operating temperature. Or critical pressure is this one. P critical is this one. See, drumless boiler, you will not get any drum here, only evaporator you will get. Then supercritical operating pressure for one screw boiler. It's supercritical, greater than 221.2 bar pressure. And we know for subcritical, it's around 175 bar, and your temperature range is 565 degrees Celsius. This is not fixed value. If you ask for any Alstom fellow or L&T fellow, they will answer something else, but it's around 175 bar. And temperature is around 565 degrees Celsius in case of subcritical boilers. Then critical already 221.2 bar already discussed. Then supercritical boilers, you will get around 250 bar pressure, then temperature 595 degree Celsius. This is approximate value. It will differ from company to company. Then for ultra supercritical, you will get around 275 bar pressure, and temperature also it will increase around 620 degrees Celsius. This is maximum temperature. Here, if you follow the Rankine cycle, your maximum temperature, this T max value is your temperature. 620 degrees Celsius is your T max value. Then for AUSC, advanced ultra supercritical boilers, you will get 310 bar pressure, and temperature it will become around 670 degrees Celsius. High grade materials they are using. In NTPC Shipati unit, you will get this one. They are doing the trial of AUSC, advanced ultra supercritical boilers, combination of BHL, NTPC and IGCR. They are testing in NTPC Shipati unit, advanced ultra supercritical boilers. Single unit they are targeting 800 megawatt. Government of India also funding this project. Next question, in a multi-cylinder heavy duty engine, mainly dash lubrication. Multi-cylinder heavy duty engines, this is pressure feed lubrication. I think it's different in books to books. You will get different answer. But I think this is the correct answer, pressure feed. You just check in any book. Then if any other answer is there, then comment in the comment box. Throttling calorimeter measures dryness fraction up to 0.98. C is your correct answer. Then next question. Bourdon gauge is used to measure pressure. Bourdon gauge. This is gauge pressure. Name itself. Bourdon tube pressure gauge used to measure gauge pressure. C is your correct answer. Then next question. All reaction turbine will have maximum efficiency if fuel velocity at outlet will be equal to maximum efficiency soil velocity, it should be 0 from option inlet soil velocity, then 0. B is your correct answer. Again problem. A diatomic gas is enclosed in a piston cylinder arrangement at a pressure of 3 bar, P1 equal to 3 bar and T1 equal to 300 Kelvin. The cylinder has volume of 1.5 meter cube. The pressure undergoes isothermal expansion to 3 meter cube. So after expansion, B2 equal to 3 meter cube. If the gas has gas constant at 1.486 kilojoule per kg using Ln2 value given 0.693. This value you have to remember. This is very important. Ln2 value in heat transfer, LMTD. This one very useful. Ln2 value 0.693 or 0.7 also you can take, no issue. Approximation. Data are diatomic gas, then your P1 is 3 bar, T1 300 Kelvin, V1 is 1.5 meter cube, isothermal expansion, so T1 equal to T2 300 Kelvin, V2 after expansion it's 3 meter cube, R value given ideal gas equation, PV equal to, from here P by T equal to MR by V. This one you have to use combining first law of thermodynamics and second law of thermodynamics. TDS relation you will get. TDS equal to mCv dt or Cv dt for unit mass, Cv dt plus PdV. This one we have to use. Then ds will integrate Cv dt PdV by T. P by T you have to get from this relation. Change in entropy or S2 minus S1, it's equal to Cv ln T, lower limit, upper limit 1 to 2 T2 by T1 plus AMR dV by V, so ln V2 by V1. This is isothermal process. It will become 0 AMR ln V2 by V1. If you remember this one also, 3 TDS relations are there. If you remember this one, then it's better. You don't have to write this many things. Directly you will get this one. You can start from here. MR ln V2 by V1. So M is the unit mass, so M equal to 1. R equal to how much? 1.486. Then your ln V2 by V1, V2 is how much? 3 by 1.5. So ln T2 you will get 0.69 or 0.7. 1.7, sorry, 1.4 into 0.7. How much you will get? Around 98 you will get. So 0.98 or approximately 1.03. From option 1.03 is the nearest value. So C is your correct answer. 1.65 not possible because already this value given, and again you have to multiply ln value, ln2 value, so it should less than 1.486. So B option directly you can omit. C is your correct answer.